What's going on, everyone? Homework assignment 49. Today's objective, I can use scale factors to solve problems. So we're going to do a mix of scale factors, using scale factors, and still using proportions, because we still can use proportions alongside the idea of scale factors. So let's take a look at our first problem that we're going to see. So notice we have no shapes, but we're being told about a few triangles. So in this event, anytime we're being told about certain shapes and they're not given to us, I suggest, I'm a more of a visual person, I suggest drawing the shape out, all right? It doesn't have to be to scale, but draw it out just so you can have an idea of what's going on. So triangle LMN is similar to triangle RST. What is the value of LN if RT is 9 inches, MN is 21 inches, and ST is 7 inches? Okay, so they're giving us some information here. So let's draw out our triangles. So let's start with triangle LMN. So I'm just going to draw a random triangle. I don't know exactly what it looks like, but that's going to be our triangle. It's going to be LMN. All right. And what are we told about triangle LMN? The value of LN, find the value of LN if RT is 9 inches. MN is 21 inches, so we're being told this, 21 inches. And ST, okay, so we're looking for LN, which is right here, so that's going to be our variable. All right, let's also draw out our other triangle, RST. So we have RST. Notice, if they say triangle LMN and RST, then since L and R are the first one stated, they should both go in the same position, followed by whichever ones are next. All right. So LMN should be in the same position as RST. All right, just making that clear for us. All right, so what do they tell us about triangle RST? RT is 9 inches. So 9 inches. And what else are they telling us? ST is 7 inches. So 7 inches. Okay. Well, they're telling us that they're similar, which means that their sides are in proportion to each other, which all it's going to do for us is tell us that we could set up a proportion. Okay. So let's go ahead and set up that proportion. So we will go with, let's go one triangle over another triangle. So let's go LMN. So we're going to say triangle LMN over triangle RST. And then we'll put the sides that correspond to each other within the same ratio here. So LMN. So let's say, let's go with that bottom LN. So X over what corresponds with X in our RST triangle. Looks like it's going to be 9. Is equal to 21 over 7. All right, cool. We can use proportions in order to figure out, we can use our cross product to figure out what our missing value is going to be. All right, some people may be already be able to see what the missing value is going to be, but let's still use it. So we will have 7x is equal to 21 times 9, which is 189. 189. Let's solve for x. So x is going to be equal to 27. Very cool. All right, and let's see if that makes sense. So if x is equal to, remember we're saying that x is equal to 27. Let's see, well, we could figure out what the scale factor is going to be. So let's say if we were trying to go from this triangle to this triangle, to get from 7 to 21, what would I do? I would multiply by 3. Well, that means that I must have to multiply by 3 in order to get from 9 to whatever this number is, and it does end up working out. It's going to be 27. So I can figure out what that value is without a proportion, but proportions will always work. All right, similar deal. We're given some shapes. We're told about some shapes, but we're not told anything else. We're told that they're similar, though. So that is big for us. So that's very helpful. It tells us that their sides are going to be in proportion. So we have quadrilateral ABCD is similar to quadrilateral WXYZ. So let us go ahead and let's make some of these quadrilaterals. So I'm going to actually use my shape tool in order to do this. All right. So we will call this one ABCD. So I'll start my A down here. A, B, C, D. All right. And we're saying that it's similar to quadrilateral WXYZ. And then we're going to start to fill in the information that they give us. And again, these aren't drawn to scale, just making that clear for us. So this is W. If I started A down there, I got to do it here. W, X, Y, Z. Okay, it's important where you write your letters, how you write your letters. Got to be consistent. What is the value of WZ? So we're looking for this right here. So I'm going to give it a variable. We have an X here. I don't want to confuse us at all. So I'm going to use the variable. Why not J? All right, we'll call it J. So we're looking for J. What is the value of WZ? If AD is 18 feet, so AD is 18 feet. CD is 27 feet. So CD or DC, better yet, is 27 feet. And YZ is 10.8 feet. So YZ is 10.8 feet. Okay. Well, we got a nice proportion that we can set up. This one is a little bit more difficult to find what that scale factor is, so we can still use our proportion, no problem. So we'll have quad ABCD. So I'm going to say let's do ABCD over WXYZ, and that's going to be our proportion, our ratio. All right. So let's pick a side for ABCD. Let's do the AD, which is 18 feet. And what corresponds to that on WXYZ? Well, it's going to be J feet. I won't write the feet for now, just because. All right. WXYZ, so it's 27 feet and 10.8 feet. All right, so those sides correspond to each other. These sides correspond to each other. All right, so let's use our cross product, and let's figure out what that missing value is going to be. So we will have 27J is equal to 18 times 10.8, which is 194.4. Divide 27 by both sides. My 27 cancels there. I'm left with J is equal to 7.2 feet. All right, so J is going to be equal to that 7.2 feet. All right, last example where we will have to use scale factor, and we will have to kind of come up with a new drawing. And it doesn't have to be to scale again. So using a scale factor of 2/3. So the scale factor is 2/3. Draw and label a rectangle similar to rectangle ABCD. All right, and we can call the triangle. We can call the quadrilateral something else. But I will bring out a new rectangle. ABCD. Maybe I'll call it EFGH, and we're going to say that it's similar. All right. So here's how we're going to use the scale factor. So I know that this side is 6 centimeters. So if these are similar, then that means that it has to be proportional to that corresponding side. All right, so it's got to be proportional to that GF side over here. So they're giving us the scale factor. So if the scale factor is 2/3, then all that I'm going to do is I'm going to take 6 and I'm going to multiply it by 2/3. Because remember, it's called a scale factor. Remember, what we do with factors is we multiply factors. All right, so that's going to be equal to 12 over 3, which is going to be equal to 4. So therefore, this corresponding side over here is going to be 4 centimeters. Same deal. I'll change up the color just so we can see. with my 9 centimeters, I'm going to take my 9 and I'm going to multiply it by 2/3, which is going to give me 6. So therefore, this is going to be 6 centimeters. And that's it. All right, these two rectangles, are going to be in proportion to each other. They're proportional to each other. And that's all that it takes. All right, so take a look at those practice problems. Let's be ready for when we come into class tomorrow. And I'll see y'all then.